Speaker is FrankA.Krueger, and he is going to be talking about functional GUIs using Fsharp. Yes. How many people here love Fsharp? Yeah? How many people here have actually used it for something? All right, good. I like y'all. All right, you'll enjoy this talk. Go for it, Frank.
All right, thank you all for coming. We have a lot of code, and it's 60 slides for me to get through in 30 minutes. So I'm going to kind of just drill into your brain. So I'm really happy that about half of you actually have seen some Fsharp before. So I'm going to present a problem that I ran into, a solution, and then I'm going to tell you how awesome that solution is. But let's start with, I love Fsharp. I've been doing .NET forever, and I actually did Fsharp years ago, but it didn't matter because I couldn't write Fsharp apps for iOS. Now I can. So I have my favorite language on my favorite platform. The thing that I like most about Fsharp, oddly enough, is it's not the succinctness of the syntax, it's the capabilities it gives you for doing data modeling. Let's just say you're writing a graphics app or something along those lines. Creating the domain for this is quite simple. We're actually going to walk through it in this. But I want you to think of your own apps while we're doing this. And I'm going to show you some primitives for doing data modeling. And I want you to think of your own little pet project and see how you can data model it. So we're going to jump right in. We're going to write a drawing program, just to remind you. And we start out with a shape. A shape can be an oval or a rectangle. This is a quick Fsharp overview. That syntax is simply or. A shape can be an oval or a rectangle. But that's boring. Let's keep adding to it. We actually have these things called records, and these are just plain old objects with public getters on everything. No public setters. These are all immutable objects, but they are basically what they read as. Very simple. So we can combine those simple records with our little shape class here. And we now have two capabilities. We can position the oval, and we can position the rectangle. This is good. But it's not enough. We've got to keep building up this drawing program. So we're going to add some more shapes. We're going to add paths, which are just a point list. We're going to add unions and subtractions, which themselves take in shapes. So we're creating a actually more rich real user model here. And to be honest, this is pretty much all you need for a drawing program, but we're going to add one more thing. There are a few common properties that users expect. You want to be able to name these shapes to keep them organized, and maybe we'll let them change the color. I'm kind of with Ford here. Everything should be black or white, but we'll allow color too. So the nice thing is, we're pretty much getting to my entire data model. This is my app. Except for one more thing, we need the document. We need a root object for actually expressing what we're going to be doing in this app. And that thing itself is very simple. So this is it. This is my drawing domain. This is why I love Fsharp. I love being able to create little domains like this. The problem is that's just a bunch of types and it doesn't really do anything. I'm very proud of it. I'd put it on a poster or something, but it really doesn't do anything. So instead, we have to somehow do CRUD operations. And the reason I have a little baboon, maybe, I don't know what he is, tiptoeing along, because Fsharp is a great data flow language. You know, start at the top, get some data, collect more data in, bring that data in. A lot of blogs don't really talk about building CRUD apps, you know, like your SQL stuff, and you're like, I want to actually open and save files. So I'm going to walk you through actually creating those operations now, given that data model that we just created. So CRUD, first one, create. So that's pretty easy. We got a new document. This really should be a function, but it turns out my new document doesn't actually take any parameters. So my function, given the awesome syntax of Fsharp, turned into a constant. So the difference between a constant and a function is simply whether you give it some parameters. So here, for example, I want to add an oval to my document. This is where things get interesting. We are never going to mutate state. You might have heard in every previous discussion prior to mine that state is evil and mutating state is evil. Well, that's the truth and you should believe it. But the fact is, users kind of want to be able to change properties and mutate state. It's just kind of what an app does. So we need a way to give the illusion that that's what you're doing, that you're overwriting these values, that you're actually doing CRUD operations. And the way we do that is quite simple. If I have a large object graph, and I want to change a property of one of the objects in that large object graph, I rewrite the entire object graph. Simple, Easy, no mutation needed. Now that might sound scary to you if you grew up in the 80s or 90s, but the fact is these functional programming languages are designed for this style of coding. So they make copying whole graphs of objects very easy. So I'm going to walk you through one of those examples right here. This is an add oval function. You can see it at the top. It takes two parameters, document and frame. The document is my root document object, that's all. This could have been a member function, but that's lame. And then it takes a parameter frame. So first line of code, boring. I'm just creating a color. Let gray equal some color. Second line of code is a little bit more interesting. I'm actually creating an element here. Now, you don't have to call new. You don't have to call constructors. You don't have to do any of that white noise boilerplate garbage code that you're stuck with in other languages. You just write the data, just data. So we have that. So we have our oval. That's an element. And now, how do we mutate our document to add that element to it? Simply, I create a new record. That's what the last few squiggly bars are. I tell it, I want my existing document, doc with, so I'm starting with my original data, and I'm telling it, precision, change one thing about it, change the elements property to be this new thing. So what it's going to do conceptually is create a whole new object graph, which is a clone of the old one, and give that back. Conceptually, semantically, that's what it's doing. But because these are all immutable types and Fsharp was written by geniuses, it does a lot smarter things and it's very efficient and all that good stuff. So how do you use it? I'm just going to reinforce the idea that we are never mutating objects. So let's start with document number 1, which is a new document. Call that function, and we get a blank document with 0 elements. Then I want to add an oval to that document, so I'm going to call the add oval function. I'm going to pass it this little bit of a mess here. It looks kind of ugly. I just inlined a frame. You know, it has a position, it has a size. It's a little ugly. I should have cleaned that code up, but I wanted to show you there are no tricks here. So I have my old add oval function, and I pass it the old document, pass it the new frame, and I get back a document with one element in it with all that stuff. Likewise, we can keep writing our CRUD functions. We need to write delete. Delete is a little bit tricky, so here's another little functional concept called mapping. This is simply, I have a bunch of data. I have a function that knows how to read that data, and it can output new data. So I have a list from 0 to 4, and I want it to be something else, but it's going to be the start of it. So I have data 0 through 4. I have a function called times 1,000. It's the dumbest function on the planet. But it simply takes a number and multiplies it by 1,000. And then I can say, take my old data, pass it through this mapping function, and I get new data back. That's all map is. It's 1/2 of map and reduce. Well, I don't have to do that for stupid, boring little lists, or even these linear lists. I have very hierarchical data. And in fact, I can write a map function to run over my entire document class. And it has the exact same semantics as the other map function. I pass in my data, a function that can do a transform, and this map function hands me back all new data with that transform applied. This code's a little bit nasty. If you've never programmed in Fsharp before, it looks terrible. If you program in Fsharp before, you say, Frank, you have a bug in it. I'm sure there's a bug in it somewhere, but I didn't actually have a chance to run this code. It's pretty close. Let's skip that, because we only have 30 minutes. But with that function, I'm now able to write my CRUD functions much more easily. Now I can write remove element very simply. Here's my remove element. It's getting clipped off, unfortunately. I pass in the document, again, the root of my object model, and then the ID of the element that I want to delete. All it has to do then is it creates a little function itself called keep, and keep just looks for things that match the ID and don't match the ID. If it matches the ID, we throw it out. That's remove. So we keep everything that doesn't match the ID. So that's only 2 lines of code. Then a more advanced example. Let's say I want to change the color of a variety of elements in that data model. Again, look at that last line of code. It's all going to boil down to a map document. So the trick is simply writing that little transform function that you have to pass to it. No problems there. This one's actually a little bit advanced because it can edit multiple IDs at a time. As you all know, you should never write a function that does one thing. It should always take an array. It should always take an enumerable just for performance, but we'll leave that aside. The beauty is we are in a mutant-free zone. We have written all of our CRUD operations without ever having to mutate a variable. So we are in a good place. Kind of. Now we have to write a GUI. This is an issue because GUIs came up in the 70s when object-oriented programming was coming up, and everyone's like, hey, object-oriented programming fits GUIs pretty neat. Let's start mutating variables to have a reflected thing on the screen. And we all take it for granted today, but if you think about it, I need to change a memory location so that something on the screen changes. It's just weird. It's such a holdover from the 70s. Either way, we're stuck with it. GUIs are object-oriented, and they're imperative. So let me tell you specifically, this is how I view object-oriented programming GUIs. And I am taking a devil's advocate approach here. I write all my code like this. I'm just starting out in Fsharp. But it really does make you notice the flaws. So let's see. We're writing an object-oriented GUI. We have a little text box. The user types something in. The text property on that text box object changes. And then you have some middleman. You might call it code behind, view model, view controllers, reactive, binding. We have all these little things to help you sleep at night so that you say, I'm not changing anything in my button handler. I'm not. But you are. That's like IOC people saying, I don't use global variables. So eventually the middleman then mutates your model. That's GUIs. I like to call this the mutant love zone. Now the thing is, Fsharp is a very powerful language. They designed it to be object-oriented also. It can totally do all of this. You can write your code as an Fsharp developer and just never do anything functional. You can just live in object-oriented land. And it's terrible. Sometimes when they teach Fsharp, they actually say that this is good or this will help you transition to Fsharp. It's terrible. Don't do it this way. Use a language for what it's good at. Fsharp is an excellent data modeling and data transformation language. Use those powers. You're not going to get those powers by pretending that it's C# or even worse, some other things. So the question that occurred to me is, personally, I love Fsharp, but I also want to create GUIs. So how do I deal with this impedance mismatch, whatever you want to call it? It's a problem for me. But like all problems, you just find an answer. So I came up with a solution. I'm sure there are, in fact, I can name you a few more solutions to the same problem. But how do I mix my beautiful functional model world with GUIs? My solution is simple. Number one, 2 points to my solution. We will never store a direct reference to an object. I will never store a pointer to that shape element or something. Instead, what I'll always store is a starting object to a graph, an entry point to a graph, or the root of a tree, whatever it happens to be, and then a way to find the thing that I want to edit. So the simplest way is to just use IDs. That's what you've seen in the previous examples. But you can imagine something like XPath or CSS selectors. Basically, you have an object graph. You need to pull something out of it without directly pointing at it. And that's an important thing, and I'll show you why soon. The second thing is I centralize all updates through one function. And I don't want to go into it super detailed right now, but it'll make sense in just a moment. So those are my two architectural decisions. So let's go back to object-oriented land. This is C# code, not to confuse you too much. This is how I write all my user interfaces right now. If I'm not using a library that's like a view model library or reactive library, if I'm just doing it, this is how I do it. I tend to prefer MVC over MVVM, but that's me. To each their own. Do what you want. But this is a classic MVC setup here where I have a controller, it has a pointer to the view, and it has a pointer to the model. What do I have to do whenever it's initialized? I set the GUI to be what the model is. Then I set up event handlers, watch the model to change, watch the GUI to change. Both things can change on me at any time, and I have to handle them. This is how I write all my apps. So you might notice some things about it. We have a direct reference to the model. That might not seem scary to you now, but it will soon. And then we have a little bit of magic, because we say model.name equals view.text. There is a lot behind those equal signs sometimes, because remember, every property is a property setter, and in property setters, all sorts of crazy binding magic can happen depending on your UI library. There's a lot of stuff behind that equal sign. So, my 2 changes. Just to repeat myself. Instead of a direct reference, we're going to have an indirect reference, and instead of magic, we're going to call updates directly. So, this is my functional name editor. This is still a controller. It's still an MVC controller. It's still pointing to both things, except I actually passed them in. The view is actually passed in. But instead of also giving it the document data directly, I'm going to introduce a class called the DocumentController, and we'll get to him in just a minute. The basic architecture is still kind of similar, though. We have to monitor the text box for events and update our model when that happens. We have to monitor our model for events and update the text box when that happens. And obviously, we have to initialize that text box. So the important part, the model changing part, where you're taking input from the user, is that first one, and it's big. It's big. Why is it big? Because we don't have that direct reference. So I have to go look through the document model to go find the actual element that I'm editing here. This is a tiny bit of code. It can be abstracted out into its own function, but I wanted to show it to you so that you saw, like, we are actually looking through and trying to find the guy. And then, once we found the element that we want to change, we use our standard map document. I love this function. And we rewrite the document and give it back. So we have this mysterious class called the DocumentController. We'll get to him in a minute. We have that indirect reference. We have an explicit update function. And we have a single updated event on the document itself. So let's look at this bad boy. That's it. That's all. That's my architecture in a nutshell, is this one class here. And all he is a controller. And whenever the document changes, remember, it's a potentially whole new object graph, it simply rewrites one field in itself. So there is one mutable field in all the classes in my entire app. Just one. That much I can handle, I hope. This might seem a little simple, but we have a private field. We expose it publicly as that capitalized data. And we have our update function. That update function sets that field. That left arrow is an equal sign in C#. And then it calls our updated event. Super simple. Again, a single source of mutation. So you might be saying to yourself, why, Frank? Why? Look, that C# code is shorter than the F#. You will never hear that again. The C# code is shorter than the F#. Deal with it. Yeah, so there had better be some benefits to doing this madness. Turns out there's 5. There's a lot of benefits. So this is one of those things where I was actually just trying to get a solution to a problem, and then I realized the solution is actually really neat. So now I'm going to try to convince you that my weird method here for doing state updates is actually pretty cool. So 5 reasons. We're going to go through them. But it starts out with, I write document-based apps. This is a world that I live in where I have to support undo and redo. All those web developers out there, you know, they've never had to be burnt by undo. They've never had to do real-time updates. It's a little artifact. Even when you're doing mobile development, you almost never have to deal with undo and redo. It's really just real apps. You know, if you're actually trying to get real work done, then you need it. The other thing that you have to support, especially on Mac, is background save and open. So these documents are getting big enough, you have to be able to serialize and deserialize your document on a background thread, which you can say, oh, that's super easy, test.run. But now you have to deal with all the potential threading issues. Imagine you're running a long transformation operation and then you hit save. You might get some mixed data being mixed in with your saved model. So doing atomic saves and opens is actually quite important. But let's do undo first, because undo is terrible. So if you read all the books on architecture and all that, they tell you how to do undo. Undo is very simple. For every operation you do, register an undo operation. Duh. The problem is, it's easy to say, hard to do in practice. So let's do it in practice. Here is my object-oriented programming undo. So my text changed, my beautiful little model.name equals view.text. That's how I mutate my model in C#. That's not good enough anymore. Now I have to register an undo function. So how does that undo function work? Well, it just does everything that the model had to be set. You can see the last line of that is the last line of that. But then you have to do all this bookkeeping, right? We're all just advanced glorified bookkeepers as programmers. It's annoying, but it works. The hard part is that is a trivial example, changing the name field of something. Imagine if you had actually an interesting transform on your data, if you were optimizing the graphic for something and merging data and sorting data, and now you have to write the inverse of that? That's impossible. You might actually have data loss, right? If I merge two objects, you can't separate them again. There is no inverse function. So that advice that all the object-oriented programming architects give you is BS, basically. No one does it that way for reals. The problem then becomes, well, I need to support undo. So here is my mutation function. Remember, I always go through update. So how do I support undo? Well, I add a little tag to the end because it's nice to have names. The truth is that I just do all my work in this little document controller. So all I did was make my document controller a tiny bit smarter. Instead of holding a pointer to the object graph that I'm going to be using, I have a list, a history of every revision that my document has gone through. Basically, I have Git up here. So I built Git into my apps. That's how I do undo. But it's super easy. So let's walk through it real quick. The update function, instead of rewriting a field and setting that field, it just adds itself to the beginning of the history, along with a little message, because you want to know what am I undoing. And then it sets the history to 0. That's just how undo generally works. Update is updated. My event doesn't change. Most of my app is fine. And then I have undo and redo functions. And these are trivial, especially when you don't do bounds checking. Then they're super trivial. So to do undo, all I have to do is point my history to another value and then tell the world that I've updated. To do redo, point it at another value, tell the world that I've updated. It's a unified approach, and it's glorious, and undo is done. Now we have atomic save. But we're lucky because DocumentController already has all of these immutable versions of the document. Think of them as snapshots. And they are independent of each other because they're immutable. You cannot hurt these things. You cannot damage them in any way. So that basically means that I can do it on a background thread in complete safety. Completely atomic, completely safe, no worries. No worries about a long-running process running in the background. Atomic save, done. Background open. Again, because these are immutable objects, they can come from anywhere. I don't care what thread generated them. I don't care what data source generated them. It's just an object. It's just a pointer, and it comes to me. Background open, done. So the 3 hardest parts I have of integrating well with Yosemite, say, are free in this architecture. Then you have the concept of background updates. This is tricky. Now imagine that you have a long-running transformation running in your drawing program. Maybe it's animating something or something. And then the user starts changing values, and then they start hitting other things, and they start mutating. Basically, a mutation upon mutation. They're all happening at the same time. You can handle that. It's tricky code. It's just a lot of scenarios you have to handle. But even better is to treat this like a database transaction. So when you start your transformation, you have a pointer of the original data, and then you've transformed it into something else. And then all you can simply say is the data that I came from what the data still is? Is the read still valid in my transaction? And you just compare the 2 objects. You say, yep, good to go. And you have background updates. Simple, transactional, atomic again. So that's done. And then the last big benefit for me is memory leaks. I have a lot of memory leaks in my apps, and so do you. The problem is when you're doing GUIs, inevitably, no matter how many middlemen you use, I don't care if it's reactive or not, there is a reference to your model pointing at your UI, or the other way. Either way, there is a referential direction between those two. And unless you are very careful to dispose of those and actually destroy them, your model can have UI resources hanging around for a long time. And UI resources are super expensive. They're what's going to kill you. You can have 10 billion CLR objects, but like 5 views before you crash. So objects are free, UI resources are expensive. So for me, the huge benefit here is that one updated function. I have one event to make sure that I unsubscribe from and don't screw up. Imagine the world where every element is an iNotify property change, and every object has 15 little events shooting off of it for every little property, and that's fanning out to more events that just fan out and fan out and fan out, and you have events everywhere and basically memory leaks. So, fix memory leaks by not leaking. All right, so just to recap, for a little bit of weirdness in that I can't support direct references and that I have to channel everything through a single update function, which honestly I think is cool, so I don't see that as a penalty. But for those 2 little sacrifices, I get this rich variety of features. A lot of these are actually user-facing features, so these are free features for the user, and I don't have to deal with programming them. So I love that architecture. I hope you can convince you that Fsharp actually has a lot to contribute to the stateful world, too. And that's it. We have